Namaste everyone. Welcome to class 11 Mathematics Chapter 3 Trigonometric Functions. Today we will be covering trigonometry and introduction, application of trigonometry in various fields, trigonometry involving right angles, angles and their measurements, degree and radian measure as unit of angle measurement, relation between radian and real numbers. Now, what is trigonometry? If you break the word in two, trigon plus metry, where trigon is triangle and metry is to measure. So, trigonometry is measuring the sides of a triangle. As you all know, triangle has 6 parts, 3 angles and 3 sides. They are called 6 elements of triangle. If you know any of these 2 parts or elements, you can find rest of the elements. Now the question arises, why do we need to find these parts or angles? Though this subject was originally developed to solve problems related to geometry involving triangles. In earlier days, trigonometry was used by ship captains for navigation, for land surveys and preparing maps by surveyors, for construction and measurement of buildings by engineers, for estimating distance of stars and planets by astronomers. There are a lot of evidences available in Indian ancient history of mathematics where we can find how the trigonometry was used. Currently, trigonometry is used in seismology, oceanography to find the heights of tides, in meteorology, designing the electrical circuits by electrical engineers, describing the state of an atom by chemists, and analyzing the musical notes. So amazing, no? Architecture and civil engineering, but obvious, and it is used in medical imaging even for CT scans and ultrasounds. And trigonometry is even used in financial markets, economics and cryptography. There are many other fields where trigonometry is used. Let us recall some basic concepts that we learnt in 10th class. In 10th class, you studied trigonometry as trigonometric ratios of acute angles as ratio of sides of right angle triangles. Let us consider a right angle triangle ABC, right angled at B. If we take one acute angle A as theta, then you must have learnt tangent theta is equal to opposite side upon adjacent side. And sin theta equal to opposite side upon hypotenuse, and cos theta as adjacent side upon hypotenuse, and their complementary angles. Now, what are angles? Angle is a measure of rotation of a given ray about its initial point. If we consider a point O and a ray leading to A, this is initial side, original ray, and the final position of the ray after rotation. If it rotates anti-clockwise, it traces an angle like this. This is called terminal ray, which is revolving. Initial ray is stationary. Initial ray, which is stationary, and this is terminal ray. It keeps on revolving. Point of rotation is called vertex. Here it is O. Now, angles are of 2 types. When a direction of rotation is anti-clockwise, see here, this is the initial ray, this is vertex, and if we move anti-clockwise, angle traced is called positive angle. Now, terminal ray is moving anti-clockwise like this. This angle is being traced in a positive direction, therefore, this angle is positive. Now, when direction of rotation is clockwise, see here, this is vertex, This is our initial ray, and this terminal ray is moving clockwise. As the minute or second hands of clock move clockwise, the angle traced is negative angle, and this is positive angle. Now, for measuring any quantity, we need units, and for measuring the angles also, there are two commonly used units of measurements of angles. Degree, you are familiar with it, and other one is radians. Now, what is degree measure? You all must have been using degree in your earlier classes for trigonometric ratios, but what it is actually? If the rotation from the initial side to the terminal side is 1 upon 3/60th of an complete revolution, the angle is said to have measure of 1 degree. Let me explain with the help of a diagram. If we take this circle and divide this circle into small parts, total revolution is divided into 360 parts, and each small part is called 1 degree. This is 1 degree. To explain it further, if we consider this as a clock, we divide one complete hour into 60 minutes, 60 parts, and each part is called 1 minute. Here the circle is divided into 360 parts, and each part is called 1 degree. Now this 1 degree is further divided into 60 minutes. 1 degree is equal to 60 minutes. Minute sign is shown by this small dash over this 60, and this 1 minute is further divided into 60 seconds. And for seconds we put 2 dash here. Now comes radian measure, that is quite new for you. The angle subtended at the center by an arc of length 1 unit in a unit circle. Now what is unit circle? A simply circle with a radius 1 is said to have measure of 1 radian. Now see, here we have taken this radius as 1 unit, and the same distance if the arc covers exactly same as radius, then this angle subtended by this terminal ray OA is called 1 radian. Similarly, if we consider another circle with radius 1 unit, means unit circle, center is O and this is initial side, and it moves and traces the length exactly 1/2 times of this radius, 1.5 times of this radius, then angle subtended at the center is said to be 1/2, 1:1/2 radian. Let us take one more example. Consider another circle, center O, and this is O is the radius of 1 unit, and if arc traces the distance 1 and 2, exactly 2 times of radius, then this angle traced is said to be 2 radians. Now we consider that arc traces the complete revolution of the circle, which is circumference. Circumference is 2 pi r. Here the angle traced is 2 pi r, but since the radius is 1 unit, if we replace it by 1, so angle traced is 2 pi radian. We have replaced this r by 1 because radius is 1. So for a complete revolution, we can say it traces an angle of 2 pi radians. Now more about radian measure. More generally, in a circle of radius r, we are not taking here 1, if we are taking the radius as r and arc is again subtending the same distance that is equal to radius, so we can say this is again 1 radian, because it is given as arc length divided by radius, where arc length is also r radius is also r. So, angle traced here is again 1 radian. As you can see, angle subtended theta is ratio of arc length to the radius, or arc length is equal to radius into angle theta. Now, the relation between radian and real numbers. Radians are nothing but real numbers that we can show with the help of this diagram. If you consider a unit circle with center O and let A be any point on the circle, where OA represents the initial side of the angle, then the length of the arc of the circle will give the radian measure of an angle which the arc will subtend at the center of the circle. Consider a line PQ as tangent to the circle, where O, if we consider as origin of real number line, and OP in the positive direction, and OQ represents negative direction in the real number line. If we rope in this OP on the circle in anti-clockwise direction, then every point on this real number will correspond to radian measure on this circle. And if we rope in OQ in clockwise direction on the circle along the boundary, then every real number will correspond to some radian measure on the circle. So, we can relate that every real number will correspond to radian measure, and conversely. Thus, a radian measure and real numbers can be represented or considered as one and the same. So, that is all for today. Today's viewers, we learnt about what is trigonometry, its wider application in the various fields, and we learnt what are angles, what are their measurements, degree, radians, and relation of radians with real numbers. In our next module, so module 2 shall cover relation between degree and radian, to convert between degree measure and radian measure, and notational convention, like how to write degrees or radians, and few more examples to strengthen the concept. That's all for today. Thank you for watching. Stay tuned. Have a good day.